Okay, the topic of this video is something called the F-test. The F-test, I would rate this particular topic in the range of 2 out of 4 stars in terms of its importance. You might not ever encounter this on a standardized exam, however you might on a regular semester exam, particularly if your instructor talks about this in lecture. Now, what is the F-test and what is it used for? Well, basically it's a test to determine whether or not the standard deviations, not the means, but the standard deviations of two different data sets are statistically different or statistically similar. It doesn't make a lot of sense why you would want to do that. We usually think about wanting to determine the difference between means, if that's statistically different. It turns out that the F-test is performed as a prelude to the student's t-test, typically. Because whether or not the standard deviations of the two data sets are statistically different is actually pretty important when you perform the t-test. Because what the t-test is essentially looking at is the overlap between the two different distributions, whether or not they could possibly overlap or not. And the breadth or the width of our data distribution is of course dependent and defined by the standard deviation. So in many of the equations that you use for the student's t-test, we assume that the standard deviations of the two different independent data sets are indistinguishable or statistically similar. It's actually an assumption that's built into the mathematics. So we use the F-test to actually test whether or not the standard deviations are statistically similar or different. If they're similar, we can use the conventional series of equations where we do the S-pooled calculation for our student's t-test. However, if the standard deviations are statistically different, we're really not allowed to use that S-pooled term, and there's a different set of equations that we need to use to perform a student's t-test. So this is what the F-test is used for. It's a prelude to the student's t-test. If standard deviations are not statistically different, that's the usual case, and that's when we can proceed as normal with the student's t. Okay? Let's just quickly run through how to perform an F-test. It's actually pretty simple and straightforward. What you need to do is use this equation to compute F calculated. We're going to compare F calculated with a tabular value from a table that's reproduced in your textbook, or you can find these online, okay? If the calculated F is greater than the tabular value, the standard deviations are statistically different. If F calc is smaller than the table, they are not. This latter one is the one that we're hoping for if we want to use the S-pooled in our equation for student's t. Okay? The equation itself is really quite straightforward. All we need to know is the standard deviation for data set A and the standard deviation with data set B. In the usage of this equation, we always set it up so that the standard deviation of A, whatever data set we call A, is larger than B. So the larger standard deviation always goes in the numerator here, okay? Notice that we also square both of those terms, all right? So it's as simple as that. Let's try a sample problem real fast. It might look something like this, okay? In this sample problem, we determine two methods are being compared to see if they produce a similar standard deviation or dissimilar standard deviation. Standard deviation for method 1 was found to be 0.79 for 4 replicate measurements. The standard deviation for method 2 is 0.24 for 12 measurements. Are these two standard deviations significantly different at 95% confidence level? So we have two different data sets for two different methods. First one had 4 measurements, the second one had 12. The second one also produces a much smaller value for standard deviation. We want to know if these two numbers are statistically different in terms of these being standard deviations. So we're going to perform this F-test. Of course, remember F calc was that simple ratio of the standard deviations squared. We always put the bigger one in the numerator, smaller one in the denominator, So I'm going to call that first experiment number A, letter A, and the second experiment is letter B. That's its standard deviation. 0.24 is the second data set standard deviation. We're going to square both of those and run our math and see what we get here on our calculator for F. If I do the math, I got an F calculated of about 10.83. The next thing that we need to do is take that number and compare it with the tabular value of F. Here I'm reproducing a table of F statistics. If you look at this table, it looks a little bit different than what we see for, say, Q-test or Grubbs test or even Students T. It's still tabular data. You still don't need to memorize these. This will be given to you on an exam, okay? But our columns and rows are things that are different, okay? Here, we've got degrees of freedom for S2, that's the second standard deviation. And here, we have degrees of freedom for S1, the larger of the standard deviations. So let's take a look back at the previous work to see if we can figure out what that has to do with. Remember, for an analysis, the number of degrees of freedom is the number of points minus 1. So for data set A, the larger of the standard deviations, we had 4 measurements. So 4 minus 1 is 3, and that's equal to what we call data set A or S1. Do a similar calculation for data set B. But here we had 12 replicate measurements, many more. But the degrees of freedom is still n minus 1. But here that makes 11. So SA is 3, SB is 11. So if we look at column labeled 3, for that first standard deviation, we know that one of these numbers is appropriate to use for our F table. And likewise, for S2, we had 11 degrees of freedom. So the number I'm kind of honing in on here is 3.59. That is F table, 3.59. So the result of our analysis, since F calc was 10.83, F calc is bigger than F table by quite a bit. And what that means is that the standard deviations of our two data sets are in fact statistically different. They're not the same. We've shown that through the F test. The significance of that would be you should not proceed by using the standard equations for the student's t-test to discuss differences between means for these two methods. Because the standard deviations were significantly different, you need to use a different set of equations for the t-test that doesn't involve S-pooled. I hope you've enjoyed the video. This has been a discussion of the F-test and importance of about 2 to 4 stars. If your instructor really stresses this type of thing during lecture, you might see it on an exam, you might need to use it, okay? So you'll have to adjust for your particular class. But if your instructor doesn't talk about this, to be very honest, you may not encounter this on the standardized final exam either. Just throwing this in for comprehensiveness. Thanks.